Hi everyone, so I am trying a new stand for my camera just to make it a little bit more easier for people to see what I'm writing and here basically. So this is mostly like a trial for this because I want to see how it goes, and you can let me know if it's a little bit easier for you to actually read what I am doing. So I'm basically just going to go on and continue with the note I've made over here. So I want to look at exercises. So exercise E, there's the one over here. Questions 3, 9, 10, 11. Okay, so just a quick revision for me as well, because I do not remember what I've done, and I might actually need to look back at all of these notes. So I've done, have I started here? I think, yeah. So I've started with trigonometric ratio. So I've done the sine, the cosine, the tan. Then I've done exact values for 30 and 60. Then we've done this lovely formulas on how to find and remember the 30 and 60 ones. Then one for 45 degrees over here. Then I looked at all of them together, so I made a table over there. And then we started showing that some bits related to sine and cosine. So we'll go a couple of methods. Then I have no idea what I have done here. I've done a proof. A proof for sine squared plus cosine squared equals to 1. So that's what I've done over there. Then we've done information about supplement angles for sine, cosine, and tan. A couple of examples over here. More examples. Oh, an example on how to find the cosine when you know the sine and you have to use the triangle. So we've done this bit. Okay, that makes sense. And then another one like this one. Great. So now I'm using the same book, so I haven't changed. Pure Mathematics. Pure Mathematics, so it's the same book, and it tells me I'm looking at exercise E. So I had a bookmark over here, so I think this should be quite easy to find. So exercise E, and I am looking at questions 3, 9, 10, 11. So question 3. So question 3 says show that A, B, and C. Question, which one? Question 9, if sine of theta is 3 over 5 and theta is obtuse, find the value of cosine of theta and tan of theta. Okay, and 10, the same idea, but with a different angle. And 11, find the value of x in each of the following given that x is acute. Okay. Okay, I think I just need to go on and see how I feel about it. So I am going to circle the questions I need to do so that I can find it a little bit easier. I need to do 3, 9, 10, 11. I'm gonna erase those bits after, but it's just for me to help me remember what I am doing. Okay, so question 3. Okay, I don't know why it takes me so long to get organized. I think it's just the whole idea of this new stand, and I feel like I need to concentrate a little bit more. So, okay, exercise E. So I'm gonna put exercise on the top. So I'm looking first. I'm gonna call them 1, 2, and 3. So show that. And A. So I've got sine squared of 30 plus sine squared of 45 plus sine squared of 60 equals 3 over 2. Okay. So I think, yeah, I'm gonna write with this one. So I'm starting with sine squared of 30 plus sine squared of 45 plus sine squared of 60. I'm not sure how they want me to do this one. Do they want me to just use the exact values? Or can I use something else as well? Can I use some of these ones? I don't know. I think I'm going to do 2 different methods. So I'm going to call it method 1. So I'm going to put a 1 there. So I think I will know how to do so. What am I looking at? I'm going to look back at the exact values to make sure I don't make any mistakes for this one. And I'm going to see if I remember the rest. So sine of 30, 1 over 2, everything squared, plus sine of 45, that's square root of 2 over 2, everything squared, plus sine of 30, that is root 3 over 2, everything squared. And this gives me 1 over 4. Am I doing the right thing? Yes. 1 over 4 plus 2 over 4 plus 3 over 4. And that straight away gives me 6 over 4, which I can simplify and divide by 2, both the top and the bottom. And that gives me 3 over 2, which is exactly the right-hand side. So I showed it. So I think that's a method. Second one. I feel like I want to play with these ones a little bit just because they use 30 and 60. So I can go on and be like sine squared of 30 plus sine squared of 45 plus, and let's say I can write sine of 60 as, let me see if I'm doing, yeah, cosine of 90 take away cosine of 90 take away 60 squared. Yes, so I've got sine squared of 30 plus sine squared of 45 plus cosine squared of 30. Now I have sine squared of 30 plus cosine squared of 30 plus sine squared of 45. And I know that sine squared plus cosine squared is 1. So this is 1 plus square root of 2 over 2 squared. So this is 1 plus 2 over 4. I've got 4 plus 6 over 4, and it's exactly the same thing. I got exactly the same idea, but I think, yeah, I think this one is, I don't know. Both are fine. Both are fine. I don't know which one. I'm actually curious which one you would like. I think both are pretty okay. And they're fun. Great. Next one. B. So B says sine of 60 cosine of 30 plus cosine of 60 sine of 30 equals to 1. Yeah, this is one of those that I know another formula that I think I haven't actually done in this chapter. Have I? No, so I'm gonna write this one with a pencil. I think I'm remembering this right. I think we have sine, cosine, cosine, sine, and the same angle. I think this is sine of 60 plus 30. I think so, which makes it a sine of 90, which I know the sine of 90 is 1. Yes, I do know the sine of 90 is 1. So it's kind of like straightforward, but we haven't done the formula of sine of a plus b. So I think they want me to use the actual values. So sine 60 cosine 30 plus cosine 60 sine 30. So I know sine of 60 is square root of 3 over 2 times cosine 30 is the same as, oh, again, I think I can do multiple methods. I'm going to call this one method 1. So cosine 60, no, what am I doing? 30 is 1 over 2? No. Is it the same thing? Yes, it is the same thing. Yes, it is the same thing. Cosine of 60, this is 1 over 2 times 1 over 2. Okay, good. So this is 3 over 4 plus 1 over 4. This makes 4 over 4, which is indeed 1. Great. Second method. Can I do a second method? Let me see. Sine of 60, cosine of 30 plus cosine of 60, sine of 30. I quite like doing these questions in as many methods as I can, and just a first look at the question. So I know sine of 60. I'm going to leave it like that. And I've just used this one in the other question over here. I've done sine of 60 is actually cosine of 30. So I can do, you know what? Cosine of 30 is actually sine of, am I doing this right? I need to look at the formulas again. I have the feeling I'm doing it right, but I want to write it properly. Yes, I am doing it. I should write it like that. So this is the same as sine of 90 take away 30. I don't know why I want to play like this, but I do. Great. I'm going to leave that one blank for the moment so I can do the start of this one and then decide what I want to do after. So this one, it just gives me sine squared of 60. And if I have sine squared there, I want a cosine squared of 60 there. So cosine 60. And this is sine of 60, which is the same as cosine 90 take away 30. So we've got cosine 60, cosine 60 again. That's cosine squared of 60. And that's 1. Because I know that sine squared plus cos squared is 1. So, yeah. So this one is this one for me, which is this one again. And then this one, I've changed to this one. And I changed to that one again. I think I can do exactly the same thing with cosine. I can change the sine into the cosine. And I can do the same on the other side. I can change the cosine into sine and do the same thing. So I think I still consider it to be like kind of the same method if I would do that again, but yeah, and fine, I feel pretty okay. C, they want sine squared of 45 plus cosine squared of 45 equals to 1. Now I kind of already used this one a couple of times, but they don't use it in this chapter. Then they don't say sine squared plus cos squared equals to 1. So if they don't, I think I'm just gonna do it with the values. So square root of 2 over 2 squared plus square root of 2 over 2 squared. That's 2 over 4 plus 2 over 4. That is 4 over 4, and that is 1, which is exactly what they wanted. Fair enough. I mean, I don't know why they've done all of the other bits, but other than that one, or maybe they do it in like a specific chapter with identities, and I've done it now, but anyway, it's still pretty fun. Great. Second question they want to do at the moment is I have sine. Okay, so I'm going to copy it down. So if sine of theta is 3 over 5 and theta is obtuse, find the value of A. I've got cosine of theta and B tan of theta. So I think this is one of those questions where they want the drawing. Yeah, I think they want the drawing for this one. So I'm going to put the SOHCAHTOA here because this is how I personally remember all of these ones. I'm going to make the drawing there. Great, let's say this is my... theta is obtuse. I can actually have it like that. Oh, I do not have a rubber here. Close by. Okay, it cannot actually look like that because they want theta obtuse. That is not an obtuse theta. How do I do it if they want an obtuse theta? I need to look at my example. Obtuse theta. Okay. Okay. Okay, so I was doing the right thing. See, I had to remind myself of these bits. Okay. So this is my theta actually. And this one over there is 180 take away theta. Good. So now if I know sine of theta, where's my sine of theta is the same as sine of 180 take away theta. That's why they give me the sine. I'm going to write it over there in a different color so that I will remember it for the other one. So sine of theta is the same as sine of 180 take away theta. Yes, that is true. Great, so if sine of this angle is 3/5, and I've got sine of 180 take away theta is 3/5 as well. And sine is the opposite over hypotenuse. And I need cosine and tan. Okay, so first of all, I think it's the same as in here. I need to use Pythagoras, yes. So I need to use Pythagoras' theorem. Great, because I have, so c squared is a squared plus b squared. My c is 5 squared is the same as 3 squared plus b squared. So 25 equals 9 plus b. Take away the 9. 25 take away 9, 16. B squared. 16b squared. So b is 4. B is 4. So this one here is 4. Great. Now I need cosine of theta. Now I need to remind myself cosine is minus sine. Yes, minus cosine. So I'm going to write it here. Cosine of theta is the same as minus cosine of 180 take away theta. So I am going to find out cosine of 180 take away theta first, because that's the adjacent, which is 4 over the hypotenuse, which is 5. 4/5. So cosine of theta is just negative 4/5. Great. And b, I've got tan of theta. Now, am I allowed to use sine over cosine? Yes, good. So I want to use sine over cos theta, not x, theta over cosine of theta. So sine of theta, where was it? 3/5. It's over or divide by negative 4/5. So I'm going 3/5 times 5/4 with the negative in front. So it is going to be negative 3/4. Done. Or, so this is a first method. This is a first method. I want to do a second one. I need my full drawing. So I want to do a second method. I don't know why I like this multiple methods, but so tan of theta minus tan of 180 take away theta, isn't it? Yes. So why have I written it like that? Tan of theta is minus tan of 180 take away theta. Great. So from my drawing, tan of 180 take away theta is, so it's the opposite, 3/4. So tan of theta is just negative 3/4. Nice. I think it's faster, this one. Anyway, third question. I've got the same idea. So I've got sine of theta as 5/13 this time. I still have theta obtuse, and I need to find, this is the same idea, I need to find cosine of theta and tan of theta. I'm going to do exactly the same bit. Lovely drawing. I'm going to make the drawing a little bit smaller. It's not a straight line, but that's my theta. This one over there is 180 take away theta. I haven't actually said these are right angle, although they kind of look. So I've got sine of theta, which is the same as sine of 180 take away theta. So this is 5 and this is 13. So Pythagoras. Let's see. So I've got c squared is a squared plus b squared. 13 squared equals 5 squared plus b squared. 13 squared. 169. Yes, 169. 169 is 25 plus b squared. I'm taking away the 25. 144, that's b squared. I do the square root, so I've got b equals to 12. So this bit over there is 12. Ace. So I can do cosine of theta. Cosine of theta is negative cosine of 180 take away theta. So that gives me negative 12/13. And the second bit is tan of theta, which is negative tan of 180 take away theta. So negative tan is opposite 5/12. So negative 5/12. I think I went really fast over these ones. Okay. So next one. Find the value of x in each of the following given that x is acute. So which question is this one for me? 4. So find the value of x. Find the value of x where x is acute. So first one, I've got sine of 50 equals cosine of x. Oh, that's this one. Sine of theta equals cosine of 90 take away theta, because I know x is acute. So I actually have 90 take away. No, sine of 50. What am I writing? Sine of 50 is the same as cosine of 90 take away 50. So I've got sine of 50 equals cosine of 40. So my x equals 40. B. Cosine of 30. Sine of x. So I'm using the other one. So cosine of theta is sine of 90 take away theta. I think I am doing the right bit. Yes. So this makes cosine of 30 to be sine of 90 take away 30. So So cosine of 30 makes this one sine of 60. So my x equals 60. C. Cosine of 40 plus x equals sine of 30. I'm going to use the same ones. So, oh, actually, I can do this the other way around. So I've got sine of 30 is actually cosine of 90 take away 30. So you got sine of 30 equals cosine of 60. So I've got cosine of 40 plus x is the same as cosine of 60. And because x is acute, I can just say 40 plus x is 60. So I can say x equals to 20. Ace. C. I'm doing D. Do I have space for D here? No, but I can start it. Okay, so sine of 20 plus x equals cosine of 50. So I will do the same method as the one I've done on the top. So I'm going to write cosine of 50 equals sine of 90 minus 50, which makes cosine of 50 equals sine of 40. So I have sine of 20 plus x. So I've got sine of 20 plus x is the same as sine of 40. And because x is acute, I've got 20 plus x equals 40. So I've got x equals 20. E. So I've got cosine of 3x minus 10 equals to sine of 10. So following the same idea, cosine of 90 take away 10. So sine of 10 is actually the same as cosine of 80. So I've got cosine of 3x minus 10 equals cosine of 80. And because x is acute, which is less than 90, I can just say the angles are equal. So I've got 3x equals to 90, so my x is 30. And the last one, cosine of 2x plus 40 this time equals to sine of 40. So I've got sine of 40 equals cosine of 90 take away 40. So you go sine of 40 equals cosine of 50. So cosine of 2x plus 40 is actually the same as cosine of 50. So I've got 2x plus 40 equals to 50, 2x equals to 10, and x equals to 5. Ace. Great. I've done all of the questions. Like, yeah, I think I went through them quite fast, to be fair. So, yeah. But I think they were pretty fun. So, yeah. So, I feel pretty good about it. If you like this way of me doing the questions, can you just let me know if you think this is like close enough to my writing for you to see every single bit that's on the page. Yeah. And yes, I think this was pretty okay. Just a quick reminder about what am I actually doing here is, so imagine people have different type of hobbies, like they read, they play games, they go for a walk, they go cycling, they do stuff like that. I am doing maths as a way for me to relax, and yeah, I will continue to do so. I just wanted to film them a little bit more often, and I was looking for a nicer stand for you to properly see what I'm doing, because I think that's the whole point. So yeah, I will go on and do solution of triangles next time. And yeah, I don't know what this whole topic is about, but I will find out next time. And hopefully I will film more of these ones. So let me know if you liked it and you will want to see more. And yeah, I will speak to you soon. Enjoy the day. Bye.